it's a marking.
One of the things I'm looking forward to the most is just rendezvousing with the Hubble Space Telescope to join up on it and to see it for the first time up close. I think that'll be pretty cool. But what we'll need to do is, from our launch, we'll have to get into the same orbit as the Hubble and get up to its altitude, which is a little over 300 miles above the Earth, almost 100 miles higher than the space station. So we'll get a little different view of the planet, maybe a little bit more curve on the horizon. But we'll get together with the Hubble and we'll get close to it. And as we get closer and closer, the commander, Scott Altman, will drive us right up to the point where Megan can use the robotic arm to actually grab a hold of the Hubble Space Telescope and then bring it down into the payload bay, and it actually latches in there. And then we'll use it kind of as our high bay or as our garage, and we'll go out and work on it then in that stable platform. This platform that we latch it onto can spin around and kind of pitch and tilt, so we can get the telescope in a good position for us to work on it. During the rendezvous specifically, I get to operate this handheld laser, which is something that I can point at the telescope and shoot a laser beam out at it, and we'll get distance information on it from that piece of equipment. And so we'll be able to tell how far away we are, obviously, and as we get closer, we'll be able to tell the rate that we're closing on it. My favorite Hubble picture, well, there's been just some gorgeous, beautiful pictures, but I think the one I like the best is that ultra deep field shot. And it's, like I said, it may not be the most beautiful one in terms of colors and, just a pretty picture, but I like what it represents, and how it was taken, because there's so much captured in that image. This is looking back really at the first light of the universe, and it's just amazing to me. It's looking back, 13 billion years from when the very first light, emerged from the universe, and it's just kind of hard to think about how far that light has traveled, getting to us, and getting into the Hubble Space Telescope, and being able to produce an image from that. And the other thing that just boggles my mind about it is that it's just looking at a very tiny slice of the sky. Not even a slice of the sky. It's like looking through a soda straw, and yet in that image there's 10,000 galaxies. And so if we tried to take a picture of the rest of the night sky, there'd be another 10 million pictures to put that whole scene together. So you start doing the math and you realize just how many stars and galaxies are out there, and then you start thinking about us here on Earth and what a small, tiny part of it that we are.
Yeah, that would take a little coordination, like maybe about 20.
And that's for any of it, who knows what can happen. Just in case we have an extreme event, we can actually, we're a terrorist if we made it in there.
Let's just turn NPT battery on and airlock.
I'm getting a runaway, I think.
Self-aware. Very careful.
Why don't we pitch the front? Why don't we pitch the front up? Okay. My right arm up. Okay, my left arm. Okay, right. So we'll just bring it down. So it looks like we've only got like an inch or so to go.
Solid.
Tape. What else we got?
Yeah, what's it going?
Yeah, I think so. From the Sierra Navigator housing by turning counterclockwise.
The amazing thing about the Hubble Space Telescope, 19 years on orbit next month, and we still have spare parts on the ground. How many 19-year-old cars still have spare parts? Well, lots of them, but not exotic cars like Hubble. And so the folks on the ground scrambled, and we knew we had most of the parts to build a new SI-CNDH box, Scientific Instrument Command Data Handling box. But we weren't really sure because we didn't need it, and so all the parts were sitting on shelves. And so Goddard had to scramble and put those boxes together, verify the history of them, that they are flight quality boxes. And in the process of doing that, they discovered that really they only had half of what they needed, and the other half had to be assembled and tested. It existed, but it wasn't in flight condition. And so the reason why we've had a delay of all these months is to be able to put the new, fully redundant SI-CNDH together, test it, vibrate it, give it all the thermal cycles that it will see on orbit, and fully test it to make sure that when we put it on Hubble this May, it'll work just fine. Given that all of the science data flows through this new box, it's been recognized with a relatively high priority on the mission. So we're going to do this on the first EVA day. What that's done is displaced the battery swap that we were going to do to the fifth EVA day. It's a relatively straightforward swap. It's very much like the battery. Drew, up at the telescope, will open the door of one of the bays, run a bunch of screws out, take the connector off, grab it. Megan will fly Drew down. We'll swap the two boxes. I'll be back on what's called the mule in the back of the orbiter, where I'll take off the new one, hand him the new one, take the old one. I'll scurry down and stow the old one so we can see what actually failed once we get it on the ground. Drew will take the new one up, slide it onto the door, drive all the screws and connectors. Voila, we have a new fully redundant box.
Why? It's big.
Yeah, this is huge.
You see that?
I can see Drew.
Just kind of hold it. I'll check it down. Is that good?
Yep.
All right.
5, stop.
I think you're in the latches.
Oh, they're riding down. Riding down.
Yeah, it's pretty low, too.
Oh, so there's stuff right there.
Cameras on mom. Yeah. I never used that. It's pretty cool. I know, but it looks good. It's be an empty box.
You can go ahead and
Look, there's a lot of direction to this thing.
yes.
Okay.
Go ahead and start on page 3.
No, that's not going to work.
Yeah. During
There you go.
the construction of this.
Yeah, that's right. Chase the threads in a little bit. Fingers.
Box straws.
Yeah. Yeah, so you will see that.
Effort. All delicious.
Oh, you're the winner.
Thanks.
Same thing actually
That's
with the
great.
breakfast drinks, although they're still pretty good. But
Yeah.
Good.
I don't want any aspartame.
So you have two chances, right? Two chances. And it's nice to have redundancy because something breaks, you have a backup. You know, you have two light bulbs in your house. So one goes out, you can still see. But if the second one goes out, you're out of luck. It's dark, right? We're back in the dark ages. Yeah. And that's the situation we're in right now. The A side is down, it failed, but the B side is working. So they're still able to get the images down from the telescope. But if the B would have failed, we'd be out of luck. So it'd be kind of silly for us to go up there and put all this new fancy stuff in there and then leave. And then if the B side would go down, you know, at some point, then we'd be out of luck. The thing would be working great, but you can't see any of your pictures, like you said. So we're going to go up there with a new box that will have a new A and B side. So it'll have redundancy, and hopefully both channels will be working, and we'll be able to leave it there with the confidence that in case this problem happens again, we won't be out of luck. They'll still have a backup channel for it. I'm starting to get. I see. You get really excited. It's like anticipating Christmas, and then like 3 days before, like no, we're not having Christmas right now. Come back. We're gonna have Christmas in July or something. That's kind of like what this was like. So I don't want to be fooled again.